Like the
Okay.
history professor that I had last semester was an adjunct. He was great.
Oh, who was your great adjunct for history?
Thomas Meeker.
Oh, yeah, he is. But I think he was full-time faculty for a long while in philosophy or something else.
He's no longer here because the school wouldn't make him a full-time professor. So he had to get a
Oh, really?
job at a high school in the area.
Oh, that's
I
funny.
just realized I left my pencil in my office. You
Adjunct
can't write
this
on the
past summer,
overhead
too.
without a pencil.
For some online classes, and I thought both of them were super great and professional.
Yeah, I
No
had,
problems.
I've had
It's just
three
nice
and
when
I
you
really
can be able
like
to email them and they'll get right back to you.
Yeah,
That's
right.
I like it well.
Okay, so have we gone over the flow of the end of the semester yet? I know I've done it for 110 and 131. Have I talked to you guys about the last few? Because we're in the last few weeks. If we were running a marathon, we'd be at mile 24 right now. Okay, we're almost there. So let's talk about what's going on in the rest of the class. So we are right now in the second to last week. Next week is our last week of class. Okay, so last week of class. On Monday, Journal 4 is due. On Friday, we're going to have Exam 4, which is our Unit 4 exam. Okay, all the rocks and minerals and stuff that we've been talking about so far. Now we still have one more class on that following Monday, on the 10th. What we're doing on that class is exactly what it says there. We're going to be reviewing excuse me for the hiccups, reviewing Exam 4. Just like we've gone over every exam, we're going to, I'm going to go over the right and wrong answers, give you time. Whoa, we are thin today. 2, 4, 6, 8, 10, 12. We're down about 8 people. Although some of those people I know why they're not here. But, so if you have a friend in the class that you're not seeing, if you're like, I usually have this person sitting over here. Yeah, well, exactly. Let's share with that person what we went over. Although obviously it's also in the syllabus. So on that last day we'll go over Exam 4 and we'll also go over review. Now I am going to try. I am not promising right now. Everybody look, this is not a promise, but I am going to try to have a study review packet for you to pick up on Exam 4 so that when you come to class on that last Monday, you have intelligent questions on the material so we can actually review for the final. Because there's no review before the final. You come in, I collect your late work if you have any, I say, go to it, you attack the final, you turn it in, you go. So usually before the exam we have about 5-10 minutes of review. That is not going to happen on the final exam, okay? Your last opportunity to review is that last day of class. Now we also have reading day. Snow has been unpredictable. I don't know, it depends kind of if there's another snow day or delay or something like that, whether or not that reading day will be gobbled up. If reading day isn't gobbled up, I am here and I will give appointments for each class when you can drop down and do a group review if you would like. Generally speaking, it still means that I'm by myself in here grading, usually speaking, because very few people usually show up, but the few people who do usually find it very worthwhile. So I'm going to try and do that if reading day is available. Does that make sense? Awesome. Remember, how many late homeworks and assignments and stuff can you turn in? Exactly 1. Okay. Yes.
Can I turn in like Journal 3 when I put in Journal 4? Because you'll just have it. Or should I need to turn my binder in again?
You turn it in at the final.
Okay.
The late one at the final. And I know it's like, but you already have my binder, Dr. Eby. Why are you? It's an organization thing. Like I do all of it in at once and all of it out. And you will be, if you turn in your binder at the final, you will be able to pick up your binder at the end of the week and actually anytime up until the first week of spring semester classes, at which point the stuff on the inside gets recycled and your binder becomes one of the free binders available for students who want to use a free binder rather than go buy a binder. Okay, make sense? Awesome. Final exam is on the 14th. It is cumulative, which means we're going to cover all the topics all the topics we've discussed so far. It is exactly the same structure as every single exam that we've taken. It's just twice as long. So that means instead of 35 multiple choice answers, how many multiple choice answers are there on the final? 70. Excellent. 10 short answer, or instead of 5 short answer, we have 10 short answer. Exactly. It's worth 300 points, so it's something to take very seriously. That's 30% of your grade right there. It's almost all going to be very much the core material of the course. There's nothing going to be weird or abstract. So if you saw it in the homework and in the notes, then it's very likely to be on the final exam. If it's something we covered briefly once, that is not something that I'm going to focus on the final exam. It's very much, did you get the core information? 8 out of 10 questions on the final exam short answer will be questions you have seen before on previous exams. There might be a tiny, tiny change, like, diagram the seasons when it is, sun and earth when it is summer in Watertown might be on the test, for original test, and in this one it says the winter, but they will be almost identical. Okay? Final exam is on the 14th, which is a Friday. It is at 11 a.m. and it is in this room. Don't be afraid if you're like, I'm getting jumbled up, but I don't want to ask the professor because I've had a professor in the past yell at me and be mean in an email because I asked a question about when the final was. I am not that professor. I would rather you ask than not show up to the final. Does that make sense? Awesome. Cool. Got all that garbage out of the way. So, what were we wrapping up last time?
Important rocks that'll be on the test.
Important rocks that will be on the test. So, what are 5 rocks that might show up on the test so far? Is it 5? It is 5. Coal. Hummus. Obsidian. Granite. Basalt. Excellent. Let's talk about a few more that might show up on the exam. So sandstone. What kind of rock is sandstone? You can look in your notes. Sedimentary, excellent, Catherine. What kind of sedimentary? Clastic, excellent. So this is a clastic, sedimentary. And if you were going to describe sandstone, what would it look like? It's got little grains of what in it? Sand, excellent. Now, you don't need to know the minerals, so I'm not going to list them here. It does have minerals. The dominant mineral, generally speaking, in sandstone is quartz, because sand is usually made of quartz. If you follow me into historical geology, we will talk all about why sandstone is made of quartz and not feldspar or another mineral. Okay, but for this class, just know that it has minerals. I'll put that there, has minerals. But, you don't need to know which minerals it is. So, can someone think of another rock that we talked about? Maybe another sedimentary rock. Coquina, not on the test. Excellent. Biochemical sedimentary. What's another sedimentary rock we talked about? Limestone. That is very likely on the test. Super likely, because that's what makes the rock here. Okay, the rock underneath your feet, underneath the dirt around here, that is limestone rock. So, it's important if you live in this area. At least as a geology professor, I consider it very important. So what kind of rock is limestone?
Biochemical, sedimentary.
Excellent, biochemical sedimentary. And what's it made of? What's it look like? It's made of calcite. Calcite is its what? Mineral. And that's important. You do need to know that because how do we test for calcite? Acid. So a possible test question is you find a rock and it fizzes. What mineral does it contain? What's one rock it could be? That kind of a question. Does that make sense? Okay, excellent. So if you look at it, what did you notice in the limestone that we saw? What do you often see in limestone? I will grab a piece of limestone. I actually went through and put a bunch of stuff away. That was a mistake. It's never a good idea to put away stuff in the geo lab. They're always playing with rocks.
Honestly, I had 2 hours of sleep the night before, so I was close my computer.
So, looking at this one right here, what do I see here and here and here and here?
Shell fragments.
Shell fragments, I see, and they're preserved in rock. What would we call those? Fossils, excellent. So it often has fossils. And why do we expect to find fossils in limestone? What is limestone really made of?
Sea creatures, ocean.
Sea critters, excellent. It's made of shells. So we've got coal, we've got sandstone, we've got limestone. Let's talk about shale. What kind of rock is shale? Sedimentary. What kind of sedimentary? Clastic. Excellent. And what does it look like?
It's
Flaky and black. Excellent. Black and in sheets. So the geology, we don't say things are flaky. What we would say for a sedimentary rock, there's a special word for flaky in sedimentary rocks, and that word is platy. Okay, now we're not going to worry about that word platy in this class anymore than we're going to work about foliations or anything like that. But there's a word for that flakiness, and it's called platy. And we're not going to worry about what minerals. It's actually a family of different kinds of clay-based minerals, but we're just going to say it has minerals. So we've got coal, sandstone, limestone, shale, and we have representatives of organic sedimentary, clastic sedimentary, and biochemical sedimentary. So what kind of sedimentary rock are we still missing? You said it right. You said it right. But what kind of rock is?
Chemical.
Excellent. So we're missing chemical sedimentary, and our representative of the chemical sedimentary is chert, which apparently my Chicago accent really comes out when I say that word. Okay, so chert, it's, we can have it smooth. It comes in a variety of colors, so we're not going to worry too much about the description. Once again, it has minerals. You don't need to know which minerals. Do you remember what minerals it contains from our discussion in class? Very hard. It can scratch glass. What's the mineral that's very hard, scratches glass, but very common? Super common. Makes up the bulk of the crust. That's a rock. We're looking for a mineral, hard enough to scratch glass. Good thought, but obsidian's a rock, not a mineral. Excellent, quartz. So chert is what's known as cryptocrystalline quartz. That means it has crystals in it, but they're too tiny for you to see with the naked eye. Okay, and that has to do with the very, very slow crystallization process that forms chert and flint and that whole family. So we got 2 spots left. Both of these are for metamorphic rocks. What's one common metamorphic rock in the Jefferson County area?
Marble.
Gneiss and marble. Both of them are right. So I'm going to put gneiss up here. Nice. I'll put marble down here. So, what does gneiss look like?
Does foliation layers in it.
Foliation layers. It has bands. Now the name, as Catherine was absolutely correct, those bands are called foliations. You don't need to know that, but it's a banded rock. What causes those bands? Do you remember that from the discussion?
Stress.
Yeah, stress, squeezing. It's squeezing and pressure. So, what kinds of minerals did we see in gneiss based on our notes?
Quartz, feldspar, biotite, and garnet.
Excellent. So garnet only shows up in a garnet gneiss, but it's quartz. What we always expect to see in a gneiss are quartz, feldspar, and micas. And biotite is a type of mica. What do I notice about gneiss? Does it have anything in common with any other rocks when it comes to minerals?
It's the same as granite.
Same as granite. So it's the same family of minerals as granite. Why is that totally expected for gneiss? Why are we like, well, of course it's got the same minerals as granite? Think about how gneiss forms.
More than one protolith.
It does have more than one protolith, but what's one common protolith in the protolith around here?
Limestone.
Not limestone. Limestone is for marble, right?
Right. Is it quartz?
It's quartz. Excellent. Well, not quartz. Quartz is one of the minerals in the rocks that form gneiss. Look at the section of important rocks of Jefferson County. It's in your notes. It should be on like literally the facing page to the rock list. I will help you because I know we're in the last. I run marathons, and I know we're at mile 24 in this semester, and I know exactly how hard mile 24 is. So, it's up on the board. What's a common protolith of gneiss, and the protolith of gneiss in this area?
Limestone.
No.
Is it-
Marble is limestone.
Granite.
Granite, where'd you get that? Excellent. So gneiss formed from granite. That means that gneiss is protolith, or at least one of the protoliths of gneiss is granite. Excellent. Okay. So it has bands, and its protolith is granite, and that's the one that you need to memorize. So marble, what does that look like? Usually. What's the sample we handed around look like? Remember that? Huh?
It's a mess.
It's a mess?
I don't know.
I don't know. Think about marble statues. What color are marble statues? White. Excellent. So it's usually white. But it can actually be a lot of different pale colors. And there are really actually black marbles as well, but they're very rare. And what's marble's protolith? Limestone, excellent. Protolith is limestone. And because of that, what mineral are we expecting in our marble? Calcite, excellent. Now I know this was a struggle, okay, and I saw that, and that's okay, because we've only handled this for a couple days, but it is the end of the semester. I know a lot of the other professors right now, you've got term papers due coming up and all that kind of stuff, so you're really, really busy. But this is a great list to turn into a bunch of flashcards, okay? Because there's different levels of understanding something or knowing something. This is the very bottom tier of that. This is just straight up knowing it, just memorization stuff, okay? So this is one of those things where it's an easy source of points as long as you practice with flashcards with it. Make sense? Okay, awesome. So, any questions about the rock list before we keep going?
Will it be laid out like multiple choice or?
This is almost all going to be in multiple choice. There might be one question about, like, for example, the testing rocks one. That's a possible one. Something similar, or another reasonable short answer question might be something like, list out the 4 types of sedimentary rocks, tell me what they are, and give an example of each. Because notice, now we have, a lot of these are great examples. So on multiple choice, for example, I might ask which one of the following is an extrusive igneous rock, okay? Or which of the following has no minerals? Or which of the following has a limestone protolith? Okay, so these are more likely to show up in multiple choice, but they could show up in one of the short answers. So, would that answer your question? Okay, awesome. Awesome. And if you need any tips for studying, I'm very happy to give those to you. So that wraps up the rocks. And we're ready to move on to earthquakes, the moving and the shaking. Okay? So earthquakes ties into this idea that Earth has layers. And a very interesting or reasonable question someone might have is, how the heck do we know that the Earth has layers? So let's start and let's make sure that we're all operating on the same page. Have we ever been to the center of the Earth? Have we ever drilled down and Excellent. That movie, The Core, terrible. Don't watch it. I can't even make it. I get about 20 minutes in and the bad science is too much. It's too bad. So no, we haven't been to the core of the Earth. How deep do you think we've dug? That's a good guess. We've actually gone about 12 kilometers. Okay, so we've gotten pretty far down, and that's just barely enough to penetrate just the oceanic crust. And the oceanic crust is much, 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 much thinner than the continental crust. The continental crust is about 150 kilometers thick, whereas the oceanic crust is only about 12 kilometers thick. So we've basically, the section that we've really drilled into and taken a look at physically is only the crust layer of Earth. So the reasonable question is, like, how do we know that the inside of the Earth actually has these layers? And what are the layers of Earth? Does anybody remember that from Earth science? Probably came into this class knowing that.
Core, magma, crust.
Core, crust, those are two parts. Magma is close, but not quite. Mantle, excellent. So we've got the core, the mantle, and the crust. And the core is divided into the inner core and the outer core. So how do we know that? So the earliest research, early research in the 1770s, we figured out, it actually goes back even older than this, but we finally figured out, we found the density of Earth. So in the 1770s, we found out the mass of Earth. Now thinking back to astronomy, and one of the questions back in the actually it wasn't in the astronomy homework, it was in the meteorology homework. Thinking back to the Eratosthenes question, how long have we known the size of Earth, its circumference and its volume? Does anyone have any idea? Eratosthenes lived like last week? We know that. Ballpark. I'm just looking for a guess. I'm not expecting you to actually have this memorized. This wasn't on any test. There's one homework question once that you didn't get tested on, so if you don't know it. But Eratosthenes, what time period does that sound like?
Roman.
Yeah, like the ancient Greeks and the ancient Romans. So we're talking, we knew the volume of Earth since around 250 BC. So we actually knew how big the Earth was and its volume for over 2,000 years. We forgot it for a bit. The Dark Ages were a hell of a thing. But we actually knew what the volume of Earth was dating back to that time. So once we found the mass of Earth in the 1770s, and this is based out of Newton's equations, we could actually find the density of Earth. And once again, having a sense of like when people discover stuff and when this stuff is researched, what important thing was going on in American history in the 1770s?
The Revolutionary War.
Revolutionary War, excellent. So probably not all the founding fathers, because not all of them were hip to science, but Benjamin Franklin probably knew that the Earth had layers, which is a cool thing to think about. So, but the density that they found was about 5.45 grams per cubic centimeter. But the density of basalt and granite are only about 2.6 grams per cubic centimeter. So, what does that mean? What does that mean for the deep inside of Earth? If the average density of Earth is 5.45 grams per cubic centimeter, but the basalt and granite is 2.6 grams per cubic centimeter. Let's stop and think. Why are basalt and granite important to this conversation? What do they make up? Crust. Excellent. So these are the two in the crust. And the crust is that surface layer of Earth. So if the surface layer of Earth is 2.6 grams per cubic centimeter, and the entire average density of the Earth is 5.45 grams per cubic centimeter, what does that mean about the deep inside? Talk to your neighbor. I'll give you a second. I don't know. Think about it. Look at the two numbers. Think about it like heights. If you know the average height of the classroom is 6 feet tall, and you know at least one person in the classroom is 4 feet tall, what does that tell you?
There's a difference.
There's a difference, but what else does that tell you? Remember, I'm almost always looking for a pretty simple deduction. So I'm not looking for like, and therefore the Big Bang Theory. Like, yeah, I'm looking for pretty small deduction here.
What was the question again?
What was the question again? We've got two numbers. This is kind of an are you alert question. And I'll put the other number over here on the other side too so you can see it. So, the average density of Earth is 5.45 grams per cubic centimeter. The density of just the crust is 2.6 grams per cubic centimeter. Remember, density is a kind of, it's mass divided by volume. Okay, size doesn't play into density. You can have a big thing that has the same density, that's very heavy, that has the same density as a small thing that's not very heavy just because it's very small, but they'll have the same density. Like A handful of lead has the same density as a room full of lead. Does that make sense? Okay. So think about these two numbers. What does that tell you about the other layers?
They're light,
Kind of, huh?
that they have a lighter density,
They have to have a lighter density?
a lower density, heavier.
Higher density. One of those two.
One of those two.
One of those
We've
two.
narrowed it down to either the inside of the earth is very dense or very not dense. Which one and why?
It's very dense.
Why?
You're gonna have the solid floated, because less dense things float up.
Right, and that's what causes it to be less dense on the surface. But why do just these two numbers? Tell us. Think back to the classroom. Whole classroom. I know this is a long walk for a short, but I believe in you. I believe in all of you. We're gonna make it to the top of this mountain together, okay? So think of a classroom. If the average